In this lecture, I am going to talk about the most important case that involves a function of two random variables. Let me call those random variables as x and y. And this is the case where we have two independent random variables. And we want to find the distribution of the sum of the two. So x plus y, and let me call the sum w, capital W. We are really interested in the continuous case, but as a warm-up, it is useful to look at the discrete case first. Discrete random variable. So therefore W is equal to x plus y, where x and y are independent, and one more assumption also I want to make it here, that is they take integer valued random variables. Okay, integer valued random variables. Now let's say we want to find the probability that the sum of x and y is equal to a particular number. That particular number, let me say W. Okay, this is what we want to find out. So therefore, since it is discrete, I am going to use probability mass function PW of small w equal to probability of x plus y is equal to a certain number W. And to illustrate this, let us take that number to be equal to 3. So this is equal to 3. You can take any value, 4, 5, 6, whatever you like, you can take it. But just for the illustration purpose, I am taking this. Nothing wrong, nothing specific in this. Illustration purpose, I am going to consider W equal to 3. Now what is the probability that the sum of the two random variable is equal to 3? To find the probability that the sum is equal to 3, you consider all possible ways that you can get the sum of 3. So what are the different ways that we need to think? And the different ways are the points in the picture. So since it is taking discrete values, both x and y, then you have different points on the place. Let's say this point is 3, 0. Therefore 3 plus 0 equal to 3. And take this point, this is 2, and this is 1, 2, 1, again 2 plus 1 equal to 3. And take this point, this is 1, this is 2, so 1, 2, again 1 plus 2 equal to 3. And this point where x equal to 1, therefore 0, 3. So 0 plus 3 equal to 3. And maybe extend this line a little bit. Then this point, if you take, this is minus 1 and this is 4. So minus 1, 4. Again, if you add the sum, minus 1 plus 4 equal to 3. Again, you can keep on do this side, and similarly you can take this side also. And this point is 4, and this point is minus 1. So this point is 4, minus 1. So therefore this is equal to 3. 4 minus 1 equal to 3. Right? So to find the probability that the sum is equal to 3, so these are the points which gives sum equal to 3, is equal to 3, you consider all possible ways. Okay, what are the possible ways? There are many possible ways. Okay, so you consider all possible ways that you can get the sum of 3, and the different ways are the points in this picture, and they correspond to a line. See, it corresponds to a line that goes towards this direction and towards this direction. So the probability that the sum is equal to a certain number is the sum of the probabilities of all those points. So the probability of the sum x plus y equal to 3 is equal to probability of 0 comma 3, then probability of 1 comma 2, then plus probability of 2 comma 1 plus probability of 3 comma 0 plus probability of 4 comma minus 1 plus uh, probability of minus 1 comma 4 and so on. So there are many points. Therefore what I am saying is the probability of the sum equal to 3 is equal to the sum of the probabilities of all those points. See, there are many points here. So what is a typical point in this picture? In a typical point, the random variable x takes a certain value and y takes the value w minus x. Suppose if I x take, let's say 2, then y is equal, let me put small x, then y is equal to 3 minus 2. So this 3 minus 2, I can say w minus x. It's a complementary value it is taking. So you are giving some value x and y equal to w minus x, complementary of that. So any combination of an x with a w minus x, any such combination gives you a sum of w. You take x, a number, and w minus x. If you add these two, you will get the sum of w. So that is over all these points of the probability that we get a certain x. Let's say x equal to 2, x equals 2. So then what happens? In this case, the corresponding probability that the random variable y takes will be 1. Okay, because 2 plus 1 equal to 3. When I consider x equal to 1, then y is equal to, when I consider x equal to 2, then y equal to 1. Okay, so anyway, so these two are complementary to each other. Now let us find out the formula for this function sum of two random variables. So Pw of small w is equal to P of, by definition, x plus y is equal to w. Okay, now this is a joint probability mass function. Joint probability mass function. Okay, now this is going to be set of all points. So look at here, there are many points. See, these all are x comma y. Let me change the color. X comma y, this is x comma y, x comma y. There are many x y's that gives rise to 3. If you add them up, you will get 3. Therefore let me consider all possible x's. So this probability is going to be sum them over set of x comma y such that this line is read as such that x plus y equal to z, set of points, so that you put a curly braces where P of x plus y is equal to w. Okay, now it is a joint probability mass function and we assume that x and y are independent, right? In that case, your joint probability mass function factors out marginal probability mass function. Therefore this I can write as P of x equal to x times P of y is equal to y. Okay, now we know that x plus y is equal to w. Therefore what is y? Y equal to w minus x. So here set of all y's such that x plus y equal to w. So this I know, how it comes. It is factors out. factors out as marginal PMF for independent random variable. Okay, therefore summation of P of x equal to x times P of what is y? Y is w minus x, right? So therefore that is given as w minus x, right? And here now this x and y is y is replaced by w minus x. Therefore let me put the variable only x. So I am writing the summation only in terms of the x. Y is eliminated here. Therefore this is going to be summation over x. Replace, this is the probability mass function px of x, and this is replaced by the probability mass function py of y. Okay, and this is pw of small w. Now why am I multiplying probabilities here? That's where we use the assumption that the two random variables x and y are independent. That is why the joint probability mass function became the marginal probability mass function. So the probability that x takes a certain value and y takes a certain complementary value, okay, that the probability is the product of the two probabilities because of the independence. So this is one probability and this is one probability. Okay, just multiply. Now when we write that into our case usual PMF notation, it is a formula of this kind. So this formula is called convolution formula. So I made a mistake here. This is w minus x. This one is y equal to w minus x. So let me rewrite this formula. Pw of small w equal to summation over x px of x times py of w minus x, and this formula is called the convolution formula. So that means we are given the PMFs of x and y and produces a new PMF. This is the new PMF. So PMF of x is given and PMF of y is given. Okay, so think of this formula as giving you a transformation PW of W. So you take two PMFs and you do something with them and you obtain a new PMF. Okay, so this procedure, what this formula does is nicely illustrated sort of by mechanically. So therefore let me take an example. So let me show you a picture here and illustrate how the mechanics go in general. So let me show this picture and then we'll see how the mechanics go. Let's say this is uniform random variables 1, 2, 3, 4. This is the x and this is a PMF of x, px of x. You take another random variable and at 1 this is 0, at 2 let's say 2 by 3, at 3 it is 0, 2, 1, and 4 it is the other way. Let me write properly. So here it is 1 over 3 and at 4 it is going to be 2 over 3 and this is y and py of y. So these are the two PMFs. So suppose that you are given the PMF of x, this one, and the probabilities all are equal probability 1 by 4 and it has this shape. So you are given a PMF of y and it has this kind of shape. So again you add the total probability here 1 by 4 plus 1 over 4 plus 1 over 4 plus 1 over 4 which is equal to 1. So it is a legitimate probability mass function, and here also 1 over 3 plus 2 over 3 which is equal to 1. This is also a legitimate probability mass function. Now we need to do this calculation for every value of w, small w, in order to get the PMF of the random variable capital W. So let's start by doing the calculation one by one, maybe just for one case. Let's assume w equal to 0. If w equal to 0, then Pw of 0 is equal to summation over x, Px of x, Py of, that is w minus where is it, w minus x, so it is going to be simply minus x. So that means what, you take the PMF of x and take the Py of y, Py of minus x on top of each other, okay, and you reverse the argument, and after that, once you do the reversal of the argument, and then do the cross multiplication, so that I'll show you now. So this is the PMF of x, and this is the 0, this is 2/3, 0, and this is 1/3. This is Py of y, and this is Px of x. 1 2 3 4, 1 2 3 4, and this is y, and this is x. Now reverse the argument. So if you reverse the argument, it looks like this. Just flip it over, okay. So this is 0 and this is 2, where 2/3, and this is 3, and 0 at 3 it is 0, and here it is 1/3, and this is 4. Actually this point is -1, this point is -2, this point is -3, and this one is -4, but purposely I am not writing as -1, -2, -3, -4, okay. Just I am reversing, okay. So it in, but I am just reversing the argument, so it is flipped over. In order to reverse the argument, what you need is you just to take this PMF and flip it. If you flip, you will get like this, okay. Now you take the multiplication of this one and this one. Now what you see here is that the function of the argument is being reversed here. So this is Py of minus x. See, x is a dummy variable after all, so I put x here, no problem, okay. So this is very important, this capital Y is important, okay, which random variable we are talking about, but this is after all a dummy variable, small x. So instead of y, I am replacing by small x, not a problem. So this is not an issue. If I write x here or y here, it's not an issue. Now then what do? We cross multiply the two plots, okay. An entry here, this point, an entry this point, and a corresponding entry here, both are multiplied, okay, and we consider all these products and add them up. So this point is multiplied by this point, and this point, and the corresponding point is here, and this point and the corresponding point is here, and this point, the corresponding point is here, this point, the corresponding point is here, this point, the corresponding point is here, and this point, the corresponding point is here, okay. So you cross multiply the two plots, and the end, so these entries are gets multiplied with the corresponding entry, and we consider all those products and add them up. But in this particular case, what happened, the flipped PMF does not have any overlap, no overlap. See, here the probability is 1/3, and here the probability is 0. 1/0 times 1/3 equal to 0, and here it is 0, and here also 0. Like this, if you do all the multiplication, finally you'll end up with a 0. So therefore for w is equal to 0, your Pw of 0 is going to be 0 in this case, in this particular plot, okay. Similarly, you can say w equal to 1. Then what happens, your Pw of 1 is equal to summation over x, Px of x times py of 1 minus x. So what is this? You take PMF py of y, then reverse the argument, that means py of minus y, then shift right by 1 unit, then you will get a py of 1 minus 1 minus y, or you can write py of 1 minus x. Instead of y, you write this a dummy variable, as I said. Okay, so therefore the original random variable is like this: 1 2 3 4, and this one is you shift right by 1, therefore this is py of 1 minus x. So this point is 0, and this point is 2 by 3, and this point is 0, and this point is 1 by 3. Okay, so this is 1, right? This is 1 2 3 and 4. So this point is 0 1 2 3 and 4. Now is there any overlap? No overlap again, therefore your PW of 1 equal to 0. See, this point at this point the random variable takes value 2, so the probability is 2 by 3, and here the probability is 0. 2 by 3 times 0 is 0, no overlap. Okay, so it is going to be 0. Now then substitute W equal to 2. So then what happens? PW of 2 is equal to summation over x, Px of x, Py of 2 minus x. So first you find out, take Py of y, then reverse the argument Py of minus y, you will get it, then shift by 2 units to the right, so you will get a Py of, let me write properly, Py of, sorry, this is x actually, x 2 minus x. So that means this one shift right by 1. One unit. So if you shift right by 1 unit, then one, 2, 3, 4. This is 1, 2, 3, 4, and this is 0. Px of x. This is x. This all are 1 or 4. Now, now this is under 1. So this guy moves to under towards 2. Therefore, and this is Py of 2 minus x. Okay. Now, what about this point? Let me check my calculation. And here also there is no overlap again. Oh my god. Okay, so this is 0, and under this it is 2 by 3, and minus 1 here, it is 0, and minus 2 here, it is 1 by 3. This is 4, 3, 2, 1. I am not writing this point as minus 1, minus 2, minus 3, minus 1, minus 4 purposely, because there is some clue here. That is why I am writing as it is. Okay, just I am flipping, and I am not changing these names. Okay, that index. Again, if you do the cross multiplication, the corresponding points from the first PMF and the second PMF, you will get a PW of 2 equal to again 0. You will get it. Okay, now next step is substitute PW equal to 3. Therefore, PW of 3 is equal to summation over x, Px of x, Py of 3 minus x. So I shift one more points to the right hand side. So 1, 2, 3, 4. Then so this comes here if it shifted to the right. So this arrow mark 1, 2, 3. Okay, this is py of 3 minus x. So in this case, here this point is 0 probability, and this one is 2 by 3, and this is 0, and this is 1 by 3. Okay, now take the term by term multiplication. So this point, the probability is 1 by 4, and here the probability is 0. So 1 by 4 times 0, no overlap. And here the probability is 1 by 4, and here the probability is 2 by 3. Therefore 1 by 4 times 2 by 3, it is 2 by 12. Okay, and here the probability is 0, and here also 0, again 0 probability. And here the probability is 1 by 3, and here the probability is 0, again this is 0. Therefore PW of 3 is equal to 2 by 12. So the first time we are getting non-zero probability when W equal to 3, small w equal to 3. And next consider the another next case, W equal to 4. So therefore PW of 4 is equal to summation over x, Px of x, Py of 4 minus x. So again take the first PMF, 1, 2, 3, 4. Then this one moves towards the right, this guy. Okay, so it comes here. This is Py of 4 minus x, and here this is 0, and below this it is 2 by 3, and below this the probability is 0, and below this it is 1 by 3. Now if you multiply term by term, this is 1, 2, 3, 4. Okay, so this also 1, 2, 3 and 4. So this point and this point becomes 0. Here the probability is 1 by 3, and this one if you multiply, it gives 0. Okay, and this one is 1 by 4, and this one is 2 by 3. Therefore 1 by 4 times 2 by 3, which is equal to again 2 by 12. Okay, and again this point is 0, and this point is 1 by 4. If you do the multiplication, this gives 0, and the contribution from here also 0, right? And let me change the color. The contribution from here also 0. Therefore 0 plus 0 plus 2 by 12 plus 0, which is equal to 2 by 12. Now substitute W is equal to 5. Then what happens? PW of 5 is equal to summation over x, Px of x, Py of 5 minus x. So in that case what happens? Just draw the diagram. 1, 2, 3, 4, and now this one moves to the fifth position under 5. 2, 3, 4, let's say 5. So here this is Py of 5 minus x. Now under 4 this point is 0, under 3 this point is 2 by 3. Wait a minute, it is not. Okay. This is 2 by 3, and if you draw, this is 0, and this is 1 by 3. Now you do the term by term. Here 1 by 3, and here 1 by 4. So 1 over 3 times 1 over 4 plus this is 1 over 4, and this is 0. So 0 times 1 over 0 is 0, plus this is 2 by 3, and this is 1 over 4. So 1 over 4 times 2 over 3, plus here it is 0, and here it is 1 over 4. So it is 0. Therefore the total probability is going to be 3 by 12. Okay, so similarly you can calculate P of 7, PW of 7. This also going to be, if you do the exercise, you will get 3 by 12, and PW of 8, you will get again 3 by 12. Okay, so the values are PW of 0 equal to 0, PW of 1 equal to 0, PW of 2 equal to 0, then PW of 3 is equal to 4 by 12, I think. 4 by 12 or 2 by 12? When, yeah, 3 equal to 2 by 12. 2 by 12, then PW of 4 is equal to 2 by 12, PW of 5 is equal to 3 over 12, PW of 7 is equal to 3 by 12, then PW of 8 is equal to, I think PW of 7 equal to 1 by 12, I think 1 by 12, and PW of 8 also 1 over 12. So 1 plus 1 2, 2 plus 3 5, 5 plus 2 7, 7 plus 2 to 11, and one more point is missing now. What is that? 1 by 2 P7, yeah, PW of 6 equal to 3 by 12. So 2 plus 2 4, 4 plus 3 7, 7 plus 3 10, 10 plus 1 11 12. Okay, therefore legitimate PMF. So if I add all the probabilities, 2 plus 2 4, 4 plus 3 7, 7 plus 3 10, 10 plus 1 11, 11 plus 1 12, 12 over 12 1. So it's a legitimate probability mass function. So if you plot the probability mass function, then this is 0 point, this is PW of W, and 0 at 0 it is 0, at 1 it is 0, at 2 it is 0, and at 3 it is 2 by 12, and 4 it is 2 by 12, and 5 it is 3 by 12, at 6 3 by 12, 5 6, then at 7 it is 1 over 12, at 8 it is 1 over 12. So 2 plus 2 4, 7 10, 12 by 12, that's it, 12 over 12. So it is a legitimate probability mass function. And there is one important point that I want to mention here. So let me take any one case. See here the W value is 4. Let me choose some other color. Yeah, I'll choose. Here the W is 4. Okay, now look at these two figures. So here the value is 1, and the corresponding value here is 3. Therefore 1 plus 3 equal to 4. And here the value is 0, and here the value is 4. Therefore 0 plus 4 equal to 4. And here the value is 2, and here also the value is 2. The random variable is taking 2. Therefore 2 plus 2 equal to 4. And here the value is 3, and here the value is 1. Therefore 3 plus 1 equal to 4. Right? So if you add the index from the first one and the second one, then again you are getting the value which is the same as what you are giving for the W. You can take any figure like here. You take this one. You take these two PMFs. Here this value is 1, and this value is what is it is? This is 0. This is 1, 2, 3, and 4. So this is 1, and this is 4. So 1 plus 4 equal to 4. Okay, and here this is 2, and this is 3. What am I doing? 1 plus, I'm sorry, this is 1 plus 4 equal to 5. Okay, so 2 plus 3 equal to again 5, and this is 3, and this is 2. So 3 plus 2 equal to 5, and this is 4, and this is 1. So 4 plus 1 equal to 5. Okay, so you take any calculation, in that the probability that the probability that this random variable is 1 times this random variable is 4. Okay, probability that this random variable is 4. Okay, that is a particular way that you can do, that you can get a sum of 4. So if you see in this figure, the way that things are aligned, it gives you all the different ways that you can get the sum of 4. Similarly, you can get the sum of 5. So, sorry, this is 5. Here you can get sum of 4, right? So you need to add the probabilities of all these combinations. So it is a kind of handy mechanical procedure for doing things, for doing this calculation, especially when the PMFs are given to you in terms of a picture. Okay, then you can do this. So the summary is, so this is how you do the calculation. The summary is as follows. So the summary of this mechanics are just what we did is that you put the PMF on top of each other. Okay, take two PMFs and put it on top of each other. You take the PMF of y or x, you flip it, and for any particular w that you are interested in, you take this flipped PMF and shift it by an amount of w. When w equal to 5, then shift by 5 units to the right. 5 units to the right. When w equal to minus 5, shift 5 units to the left. That's it. To the left. Okay. So given this particular shift for a particular value of w, you cross multiply the terms and then accumulate them and add them together. Therefore, the summary point, let me write down here. So it is, put the PMFs on top of each other, then flip the PMF of y, shift the flipped PMF by omega to the right if w is greater than 0, and to the left if w is less than 0, and cross multiply, add. Okay, so that's how you get the probability mass function of the sum of two independent random variables. Okay, now next let us move on to the continuous case, our favorite model. So we are mostly involved with the continuous case. Suppose that x and y are independent continuous random variable. Random variables, okay, with let's say the PDFs fx of x, and this guy has the PDF of fy of y respectively. Now we wish to find the PDF of, let's say w equal to x plus y. Okay, now this you can derive mathematically, but before that let us talk about this intuitively. What will happen? Let us compare the discrete case and the continuous case. That is the reason we have gone through the discrete case. Okay, so now you can ask, what would you expect to happen in the continuous case? Well, the story is familiar. Okay, in the continuous case, pretty much almost always things work out the same way, except that we replace PMFs by PDFs and summations by integrals. That's all. That is the only difference you do it. So therefore one shouldn't be any surprise here, okay, that you get a formula of this kind. So the formula is going to be like, let me write down the discrete case and then let me write down the continuous case. So in the discrete case, Pw of small w is summation over x, Px of x, Py of w minus x. Now simply what you do, replace the summation by integral, okay, and PMFs by density function fx of x, and this is Fy of w minus x times dx, and here this is Fw of small w. So there is no surprise here. So essentially what this integral does is it fits a particular w of interest. You choose any w value of interest and then you do the integration. Okay, first freeze the w and then do the integration. So we are interested in the probability that the random variable capital W takes a value equal to little w or very close to it. So therefore w is equal to a small w. For that you carry out the integration. Therefore this corresponds to an event, and for that event I need to find out the probability. So when you fix the line like this, then because w equal to x plus y, so the line is like this in the continuous case. This is x and this is y. When in this line y equal to 0, so therefore this is w and this also w. So this line is x plus y equal to w. So we need to sort of add probabilities along this line. But since the setting is continuous, we will not add probabilities, but we are going to integrate. If it is a discrete in the previous case, then we will add the probabilities along this line, right? That's what we did. But here this is not discrete. Since it is a continuous, then what you do? Integrate. So this is the concept behind this continuous random variable. So for any typical point in this picture, the probability of obtaining an outcome in this neighborhood has something to do with the density of that particular x and the density of the particular y. Okay, that would be complement of x in order to form a sum of w. Okay, so you are thinking about a particular x and a particular y, and that particular y is the complement of the x. Okay, now this is the concept behind this. Now let us do the derivation part, how this formula comes. So the derivation can be done in one or two ways. So I will take one, and that is a little easy to follow. So therefore towards this goal, we will first find the joint PDF of x and y, x and z. Okay, so and then integrate to find the PDF of z. So let me find the probability of this event, capital let me say w, because I am using the notation w, not z here. So capital W is less than or equal to small w, given that x equal to x, some particular value x is given. So what is this event? This w, we know that x plus y, right? So this I can write p of x plus y is less than or equal to small w, given x equal to x. Okay, and this one p of, say x equal to, given this is given, therefore replace this x by small x, particular value is given, therefore the random variable is replaced by a small value x. X plus y is less than or equal to w, given x equal to x. Right, now we know that this y and this x are independent. That's our assumption, right? So we know that p of a given b is equal to p of a intersection b divided by p of b. For independent events, this is equal to p of a times p of b. Then Wait a minute, I'm writing something messy here. So when I say independent events, then P of A given B is equal to P of A, because this B will not give any information about A. So in that case, this event I can remove this guy. This guy I can remove, because it is an independent event. Okay, so that will not give any information about my random variable y. This is my random variable y. Why is it random variable? Because this is the value, known value. Known value plus random variable is again a random variable. Okay, so therefore P of x plus capital Y is less than or equal to W. I can write like this. Now this is P of y is less than or equal to W minus x. Okay, so that's how it has come. Okay. Now what is this? This is a CDF, right? So CDF of y is W minus x, and in the left hand side, if you look at here, this is PW of W, FW of W. Now take the this is W given x. Okay, so this is a CDF of W given x. So take differentiation, then F W of x given W. Sorry, this is one more notation mistake here. Concept wise this is same. This is given the value x, and this also given value x, which is equal to Fy of W minus x. Okay. Now what we want is we want FW of W. So how can I do that? We know there is a formula. What is that formula? Says if we have a joint formula like this, let's say f x comma w of x comma w, which I can write as fx of x times f z given x is a conditional density rule, so you can use this z. Sorry, I'm using different notations. I don't want to confuse. F W given x. So this formula is similar like P of A comma B is equal to P of A times P of B given A. Please recall. So instead of B I have W, instead of A I have x. Okay, this A is compared like this. Okay, so instead of A I have written fx of x. So in that way you can remember this density function. Now from this, how can I get FW of W? You just know this is a joint PMF. Joint PMF. From this I need a marginal PMF. Marginal PMF. So how do you get the marginal PMF? Integrate out with respect to x, so that you will get the W. Integrate out with respect to x. So therefore this one is integrate minus infinity to plus infinity fx of fx w comma x comma small w, which is both side. Okay, do the integration with respect to x, and here integral of the right hand side, it is going to be minus infinity to plus infinity fx of x. Then this is going to be fw. What happened in the right hand side? W given x of wx. times dx. Now if you carry out the integration, then this x term will go away, this will go away, and this will go away. You will get the marginal density function. So fw of w, the right hand side, minus infinity plus infinity, fx of x. And what about this one? This one just we derived. Okay, so this one is this one here. So let me compress the screen a little bit. So okay, so f w given x, the random variable w given x of w given small x is this guy fy of w minus x. Therefore this is fy of w minus x times dx. And finally we arrived the convolution integral formula. This formula is entirely analogous to the discrete one, okay, except that the summation is replaced by an integral and the PMFs are replaced by the PDFs. Okay, so that is a only difference. Therefore summation replaced by integral and PMFs are replaced by PDFs. That's it, no other difference. So it is more or less analogous. So whenever you have summation of independent random variables, then you take the convolution of those two random variables in order to obtain the distribution of the new random variable, okay, function of those two random variables. Okay, so in this lecture I have discussed the discrete random variables and continuous random variable, and first I derived the discrete random variable with an example, and then we moved on to continuous random variable. So therefore if you have, whenever you have two random variables and if you want to sum the two random variable and find the distribution of the sum of the two random variables, then you do the convolution. If it is a discrete random variable, take the convolution sum, and if it is a continuous random variable, then you take the convolution integral. Suppose if you have more than two random variables, then what you do, let's say x plus y plus z, then first you find the x plus y, let's say that is w, then w plus z, again do the convolution. So two times you have to do the convolution, and then you can find the distribution of the summation of these three random variables. First you find out the x plus y using the convolution integral if it is continuous, and then you will get a result. Let me call that random variable as w, and then w plus z. Again apply the same convolution formula, that is a convolution integral formula, and get the final random variable. Let me call some other, let's say m. Okay, so that's it. So like that you can work on it. Okay, so with that let me stop, and in the next lecture let me continue from this. Maybe I'll talk about two independent normal random variables. Suppose if you have two normal random variables, and if you sum them up, how does it look like and what are its behavior, and etc. Okay, thank you very much.